We're going to be graphing polynomials. We're going to took what we learned in 1.4 and apply it, but this time we're going to try to do it and sketch it without a calculator. Of course, I'm going to guide you along the way through some discovery, but make sure that when we sketch a polynomial altogether, you're following certain steps because we want to make sure we have those zeros, the end behavior, so on and so forth. So here we go. We're going to use our graphing calculator right now to graph this so we can see what it looks like. So y equals, I'm going to go x, the x button again is right here, x minus 3 times x plus 2, and that one is squared. Okay. Now, my window, by the way, is set to -10, so let's see if that fits. Okay, as you can see right here, that doesn't fit the total graph, but if I were to sketch it, right, it would look something like this, and it comes around, goes up, right? All right. According to the fundamental theorem, how many zeros should this function have? Okay, well, this here is x to the first. Here, this would be x squared. And when you multiply these two together, we get x cubed. So according to the fundamental theorem of algebra, we should have 3 zeros. Many of you asked yourself this last class. But as you can see, how many times are we crossing this x-axis? Only twice. Where are we crossing? Well, if we look down here, we would be crossing at -2 and 3. Okay. So that's kind of weird because we're only crossing it twice. So what's going on? Well, this is where we get into multiplicity of zeros. So the idea is repeating zeros. And as you can see here, this is to the first. But if we were to expand this, it would be like saying x minus 3 times x plus 2 times itself. So we have a multiplicity here of this zero. It happens twice. So what's really important is that the exponent tells us the multiplicity. So in this example here, when I have x minus 5 to the 4th, it means that the zero of 50, right? What makes that 0? 5. It has a multiplicity of 4, that exponent. And this is, we're going to discover this a little bit more. Okay. So example 1 here. Use technology to graph the polynomial, identify the zeros, their multiplicity, and determine whether they touch or cross at each 0. All right, let's put this in here. So x minus 4 squared times x minus 1, that's cubed. 3. There we go. Graph. Okay, so this graph, I'm going to sketch it out just so we can see it. We've got this right here. It comes up, down, and up. All right, let's look at those zeros. So right here we have a 0 at 1, and we have a 0 at 4. Right, that makes sense here because what makes that 0, 4? What makes that 0, 1? Now, when I write these things in a chart, you want to go from smallest to largest because that will help us sketch it later. So of course, our zeros are 1 and 4. Now remember, multiplicity comes from the exponent. So the exponent for the 1 value would be 3. And the exponent for the 4 value would be 2. And we're going to discover this right now. Cross or touch. So at 1, did it cross the x-axis or did it just touch it and flip back around? As you can see, we went through the x-axis. So this is a cross. Eventually, guys, I'm fine with you saying C or T. And then here on 4, as you can see, we don't cross through, we bounce back up. So we're just touching the x-axis. All right, let's see if we can discover something as we do another one here. So again, let's take our calculator. Let's plug this in. 3 times x minus 1 squared times x plus 2. Graph. Okay. See, let's sketch this out just to see what happens here. So we go up, around, there we go. All right, so this intercept right here looks like it's at 2 and -2, right? We're on the left side there. And we're at 1. Okay. This makes sense, of course, according to our zeros, right? What makes this 0? Well, 1 does. What makes this 0? -2. Like I said, better to put it in order. This will be for future use. So we have a 0 at -2, a 0 at 1. Well, let's go back. The -2 comes from here. What's this exponent? Just because it's not there doesn't mean, or just because it's not showing a number doesn't mean it's 0, it's 1. And then for the 1 right here, our exponent is 2. All right, so at -2, did it cross or touch? It crossed. And at 1, did it cross or touch? It touched. All right, so if we went back and forth between these two examples here, what do you know that is the same about being able to cross or touch? Well, if you guys notice, the even multiplicities, so this one right here and this one right here, they touch. So even multiplicities touch the x-axis. And the odd multiplicity, look, this 3 right here crosses. This 1 right here crosses. So the odd multiplicities cross. All right, so I'm going to have you pause the video and do the first 2 questions on your check. Now, yes, number 1 is actually having you practice factoring, and this will help us later on in the lesson. So try that now. All right, hopefully you guys got that checked, because now these calculators go away. Okay. So let me get where's my highlighter? Probably can't find it. Here we go. So what we're going to do now is put everything together. We're going to look at our end behavior. We're going to look at our zeros, our multiplicities, and whether we cross or not. Now, why do we have to include end behavior in this? Because just because it touches right there doesn't mean that it's automatically touching on top. It might touch on the bottom. And our end behavior is really going to help us with that. So the reason why I had you practice your factoring in number 1 was because you have to recognize the difference of squares. Sometimes this will happen. You should know it's a difference of squares when the x squared is on the inside. So see how the square is on the outside here? It's on the inside, and it's a subtraction. So before I even fill out this chart, I need to expand this. This is x plus 3 squared. And if we do the difference of squares here, we have x plus the square root of 1 is 1, and x minus 1. Okay. Let's fill out the chart, and then we'll do the end behavior. So our zeros, I like writing them down below, are -3, -1, and 1. The reason why I write them down below is because now I can put them in order here. -1. Nope, nope, -3 is smaller. -1, 1. Now let's go back to our multiplicities. The 3, the exponent is 2. The -1, the exponent is to the first. And the 1, the exponent is to the first. And we looked up here, right? Even is touch, odd is cross. So 2 is even, so we're going to touch. 1s are odds, so we're going to cross. Now remember, the touch and cross come from the multiplicity, not the zeros. All right, so really at this point on our graph, and I'm going to put it right over here, all we know is that we have 3 zeros. So at -3, we have a point right there. At -1, we have a point. And at 1, we have a point. Okay, we don't know if it crosses one way or the other or touches on top or the bottom. We have to use our end behavior to help us. If you remember, end behavior comes from the degree and the leading coefficient of the whole polynomial. So the way to find the degree is to add all of these up. So see how I'm putting degree right here? Actually, if you add all these up straight down, that gives you your degree. So the degree is 4. It is a positive value because there is no negative sign there. So now we know that the end behavior, and what I would like you to do just for end behavior is kind of show it. So my end behavior for an even positive, both go up. Ready? Now with sketching, after I plot my zeros, I draw my end behavior. All right. Now this is why I put this in order, because we're going to touch, cross, cross. So right at this -3, we're touching. So we don't go down here. That would be a cross. Touching means we're going to bounce back. I don't care how far you go up. As long as we come back down right here, we get through that 0. And as you can see, we're going to cross. Now the next one, when I get to that 0, this crosses, and I can double check. Yep, it's supposed to cross, and we're good to go. The reason why I know it's not upside down is because of that end behavior. So we're going to try these next two. Okay, as you can see, we have no x squareds on the inside, but we have 3 ways that we can have our zeros. These two are obvious, right? That would be 2. That would be -5. When there is an x out here, it's just 0. So I'm going to put them in order: -5, 0, and 2. The -5 is to the 4th multiplicity. The 0, well, as you can see, that's x to the first, so that's first. And this one is cubed. So, ready? Even is touch, odd is cross, odd is cross. Okay. And behavior or degree. Okay, let's look at the degree first. Remember, the degree comes from adding. So we get 8, and it's a positive. So I know my end behaviors both go up. All right, plot your zeros first. So -5, 0, and 2. Plot your end behavior, right? They both go up. And then go in order. -5, well, that touches, so we come back up here. Now we're going to go back down to that new 0. At that new 0, it crosses. Come back up to that 0. It crosses again. As you can see, guys, this graph here almost looks like the one we just made. The zeros are different. The way it might come all the way up here, all the way down there, might just trickle along. We don't know what's really happening on the inside, except where it crosses and touches at the x-axis. All right, trick 1. See how I want you to change this right now? I need you to change it so when you look back at your notes, you're able to see that I changed this. I want you to make this a -2. Okay, because we got to practice those negatives. And then there's another trick. It's right here. Okay, the reason why I can say -5 to this part right here is I say, what makes that 0? So really what I'm doing is saying x plus 5 equals 0, and then I'm solving. So that's where I get that -5. But as you can see right here, if I put that on the side and I said 3x plus 1 equals 0, I have to do a 2-step equation. I get 3x equals -1, so x equals -1/3. And then our other 0 here is at +5. I do not have a 0 like I did in part B because I don't have an x out front. The multiplicity for the 1/3 is 2. The multiplicity for the 5 is 3. Again, even we touch, odds we cross. And behavior, right? So I'm going to add these. I get 5. So I know the degree is 5. But this time I also see that out front I put a negative because I wanted it to be a negative, which means if you remember from 1.4 that a negative odd on the left side it goes up, on the right side it goes down. Okay, remember that's that negative because the positive is the other way around. We flip it. All right. So how is that going to change our graph? Well, if you guys want, just put the -1/3 down instead of making it exact. And then the 5. Okay. Now, do our end behavior. Our left side is going up. Our right side is going down. Now let's talk about our inside of touch and cross. At -1/3, we're touching, so it goes back up, comes back down. Right here we cross. Does it cross? Yes, we do. And we were able to sketch it without a calculator. Next level, we're almost done. We're going to sketch it and then write an equation for it. So what helps us is that table. So I recommend making that table. Now the good thing is they give us all the zeros in the multiplicity. What we need to figure out if it touch or crosses. So we have a 0 at -3, at 4, and at 5. The multiplicity is 2, 3, and 1. Even is touch. Odd is cross. Right? Okay. Now the other thing, negative leading coefficient. Well, what that means is when we add these up for our degrees, which the degree is 6, it is now a negative, so it flips. So that end behavior for that even negative, that end behavior looks like this. So we're going to sketch it out. So at -3, at 4, and at 5. The end behavior is both going down. At -3 here, we're touching, so it comes back down. And then get to that next 0. That next 0 crosses and crosses again. Now, when you're writing the equation, be careful, because remember, these are the zeros. And if you remember from up here, we're going to look at the opposite. So even though my 0 is -3, I'm going to write x plus 3. And that multiplicity is 2. Right here, the 0 is 4. So I'm going to say x minus 4. That multiplicity is 3. And then my final is x minus 5. And that multiplicity is 1. So you can write that one there, or you don't have to. See if we can do one more, and then you guys can practice on your check questions. So even though I don't give you a table, that table is a great thing to organize yourself. So we have a 0 at -6 and at -2, multiplicity of 1, multiplicity of 4. So remember, odd multiplicities we cross, even multiplicities we touch. If I add these up, I get 5. So I know the degree is 5. And it says positive leading coefficient. So when I think of a positive odd degree, my left side goes down, my right side goes up. So -6, 3, 4, 5, 6, and at -2. Okay, let's look at those end behaviors. So this side goes down, this side goes up. All right, at -6, we're going to cross. So this is -6, I'm going to cross. And then I'm going to come back down to that next 0. And as you can see on that next 0, I touch. Does that match? It does. Okay, let's write our equation. Remember, we do the opposite. So it's going to be x plus 6 with the multiplicity of 1, and x plus 2 with the multiplicity of 4. We're all done. So do that double check there, and then you guys can practice on your own.